Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. So coming to the next concept in this particular chapter, we have acceleration. So what do you mean by acceleration? So acceleration is nothing but change in velocity in a given instant of time. That's it. So let's assume that an object is traveling at 10 meter per second and in the same direction it has changed its velocity to 20 meter per second. So let's assume that. That means this particular object has accelerated. That means it has changed its velocity with respect to time. So this change in velocity with respect to time. So change of velocity with respect to time can be known as acceleration. So here change in velocity with respect to time. So in a particular given interval of time, it was traveling at this particular speed or this particular velocity, and next in the same given interval of time, it is increasing its coverage of a particular distance. So for example, an object is covering distance between A to B in 1 second. From B to C, which has same distance, it is taking just 0.5 seconds. That means here it is taking lesser and lesser time to cover the same amount of distance, or in equal interval of time it is covering more and more distance. That means here velocity is constantly or non-uniformly changing. So that means here this particular object is accelerating. That means the amount of distance covered by this object in given interval of time. So let's take 1 second as the interval of time. So in first 1 second it covered this much distance. In next 1 second interval it has covered this much distance. Again in next 1 second it has covered still more distance, and in next 1 second the distance covered by this particular object reduces. So that means here there is increase in or decreasing coverage of distance in the same interval of time. So that's why here velocity is changing of that particular object, because here the distance is different. So here the velocity will be v1. Here the distance covered by this particular object in 1 second is different. It is actually more than this particular first distance covered. So that's why here it will be v2, here it will be v3, here it will be v4. That means here velocity is changing. So this rate of change of velocity or the change of velocity in given interval of time is known as acceleration. So acceleration simply depends on velocity and time. That means how much a particular velocity of a particular object is changing with respect to given interval of time. So that will actually tell you the acceleration of that particular object. So this is one particular concept which you should actually remember. So the more details about velocity, acceleration, vectors, scalars, all these concepts you will be learning in your higher class. So here also in acceleration you have two kinds. One is non-uniform acceleration and the other is uniform acceleration. So what do you mean by non-uniform acceleration and uniform acceleration? Here if a particular object is following a constant increase in its velocity. So for example, if a particular object was covering 5 meter in 1 second, and if the same object was covering 10 meter in 1 second, and if the same object is covering 15 meter in 1 second, so here you can see there is constant increase in the coverage of distance in the same 1 second duration. So that means here the velocity is constantly increasing. Here you can see 5 meter per second is the velocity. Here you can see 10 meter per second is the velocity. Here you can see 15 meter per second is the velocity. So here velocity is constantly increasing. That is 5, 10, 15. That means here you can see difference between 5 and 10 is 5. Here you can see difference between 10 and 15 is 5. That means constantly the velocity is increasing. That means the amount of distance covered in 1 second is going on increasing in a constant manner. So this kind of change in velocity, where velocity is constantly changing, so that particular constant change in velocity will be accounted for uniform acceleration. So that such kind of acceleration can be known as uniform acceleration. And if it is having a non-constant velocity, that is, velocity is not constant, sometimes velocity is increasing and sometimes velocity is decreasing, so randomly the velocity is increasing and decreasing in between, so that is actually accounted for non-uniform acceleration. That means velocity is not increasing or decreasing constantly, but randomly velocity is actually increasing and decreasing. So such kind of acceleration, of course, well, change in velocity is known as acceleration. If that change in velocity is happening uniformly, then it is known as uniform acceleration, and if it is happening non-uniformly, then it is known as non-uniform acceleration. That means, let's say a particular object was covering 5 meter in 1 second, then the same object will cover 7 meter in next second, and it will cover 10 meter in next second. So here you can see, to cover 5 meter it was taking 1 second, so velocity was 5 meter per second. In the next instance it was taking 1 second time to cover 7 meters. So 7 meter per second is the second velocity. And if you consider the third velocity, that is in the third second, so it was covering 10 meter. That means the velocity will be 10 meter per second. So now if you take difference between these two, so difference between 5 and 7 is 2, and difference between 7 and 10 is 3. Here you can see 2 is there, and here you can see difference 3 is there. That means constant increase in velocity is not happening. So this kind of acceleration is known as non-uniform acceleration, and this particular constant increase in velocity, here you can see 5 meter per second, velocity is increasing every instant, that is in every second. So that means here constantly the velocity is increasing. So this kind of increase in velocity, constant increase in velocity, will be accounted for uniform acceleration. So based on this particular velocity, speed, acceleration concepts, you have certain problems which is actually discussed in this particular chapter. So I'll go on solving those problems. So coming to the example 7.1, which is there in this particular chapter. So in example 7.1, an object is covering 16 meter in 4 seconds. So the next 16 meter it is covering in 2 seconds. So now you should actually calculate the average speed. So average speed always depends on total distance traveled by a particular object divided by total time. So what is total distance here? It has covered 16 meter plus 16 meter. So 32 meter is the total distance covered by this particular object, and it has taken 4 seconds to cover the first 16 meter and 2 seconds to cover the second 16 meter. So 4 plus 2 is 6 seconds. So here total time is 6 seconds. So average speed will be equal to 32 meter divided by total time is 6 seconds. So 32 divided by 6 will be equal to 6 5s are 30. Point, when you keep point it will become 20. So 6 3s are 18. So again it will be 2. So again if you take 0 it will be 20. 6 3s are 18. So it goes on like this. So 5.33 meter per second. So here always you should remember SI unit of speed or velocity will be meter per second, because here you are considering distance by time or displacement by time. So here unit for displacement will be meter and unit for time will be second. So that's why SI unit of velocity or speed will be meter per second. Similarly, if you are considering acceleration, so in acceleration you are considering the rate of change of velocity, that is change in velocity with respect to time. So that means here the SI unit of velocity will be meter per second divided by second. So that means here this second will also come to denominator. So it will be meter by second into second, that is actually meter per second square. So here meter per second square will be the SI unit for acceleration, and meter per second will be the SI unit for speed and velocity. So that's why here average speed is 32 meter divided by 6 seconds. So it will be 5.33 meter per second. So always you should remember, you should never forget to put SI unit for the physical quantities which you are actually calculating. So here you are calculating average speed and the SI unit of speed is meter per second. So that is actually total distance by total time. So 32 by 6 will be 5.33. So 5.33 meter per second is the answer for this example 7.1. So coming to example 7.2, here the odometer of car showed that Initially, before starting the trip, 2000 kilometer was recorded on it, and after completion of trip, 2400 kilometer was read on that particular odometer of the car. So here, how much distance this particular car has taken? You can calculate that. So the total distance traveled by this particular car will be equal to 2400 minus 2000. So 400 kilometer is the total distance traveled by this particular car, and the time taken to cover this particular 400 kilometer, the total time taken by this car is equal to 8 hours. This is the data which they have given. Now you should calculate the average speed of this particular car in kilometer per hour and also in meter per second. So you should remember, always when converting from kilometer per hour to meter per second, you should always be careful in conversion of SI units. So now first let us calculate in kilometer per hour. So average speed will be equal to total distance traveled by total time. So what is the total distance traveled? 400 kilometer, and the total time taken for covering 400 kilometer is 8 hours. So now 8 ones are 8 fives are 40. So 50 kilometer per hour. So 50 kilometer per hour is the average speed of this particular car. Now you should convert this average speed into meter per second. So here always you should remember kilo represents 10 power 3. So kilo is for 10 power 3, mega is for 10 power 6. Like that it goes on. So now here in the place of kilo you can put 10 power 3. So this will be 50 into 10 power 3 meter per hour. So how do you convert this hour? So you all know that 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. Now if you want to calculate this 1 hour in seconds, then 1 hour will be equal to 60 into 60 seconds. 1 minute is equal to 60 seconds. So 60 minute will be equal to 60 into 60 seconds. So what is 60 into 60? 60 into 60 is 3600 seconds. So in 1 hour you have 3600 seconds. So that means if you want to convert 1 hour into seconds, then you should actually multiply this 1 hour with 3600. So when you multiply 1 hour with 3600, you will be getting 3600 seconds. That means 1 hour is equal to 3600 seconds. So now if you want to convert anything into hour, you should actually, anything into seconds, you should actually multiply that with 3600 seconds. So now coming back to the problem, here we got average speed is equal to 50 into 10 power 3 meter per hour is there. So you should remember hour is in denominator. Now you should convert that hour into seconds. So you should multiply 3600 second to the hour. So that means here hour is in denominator. So 50 into 10 power 3 meter hour, I can write it as 1 hour. So divided by 1 hour because hour is in denominator. So now 1 hour can be written as 3600 seconds. So that means 1 hour or the unit 1 or the magnitude 1 will be multiplied with 3600 and hour will be converted to seconds. So that means in the denominator, in the place of hour, you will be writing 3600 seconds. So now you should divide this 50 into 10 power 3 with 3600 seconds so that you will get in meter per second SI unit. So now you have average speed is equal to 50 into 10 power 3 is 50,000 meter per 3600 seconds. So now two zeros gets cancelled with each other. So now we have to divide 500 with 36. So here when you divide 500 by 36, so here 4 ones are 4, 1 will be remaining, 10 will be there, 4 twos are 8, 2 will be remaining, 20 will be there, 4 fives are 20. So 125 is there. So 125 divided by 9. Here 9 ones are 9, 9 ones are 9, 3 will be remaining, 35 will be there, 9 threes are 27, 35 minus 27 will be 8. So 80 will be there. When you take point over here, it will be 80. So 9 eights are 72. Again 8 will be there. So 9 eights are 72. So it goes on like this. So 13.88 will be the average speed. So 13.88 meter per second is the average speed. Here SI unit is meter per second, and if you calculate the same in kilometer per hour, it was actually average speed is equal to 50 kilometer per hour. So in kilometer per hour unit you have 50, and in meter per second you have 13.88 meter per second. Coming to example 7.3 in this particular chapter. In example 7.3, here a particular girl is actually swimming in a particular swimming pool. So to reach the opposite end of swimming pool and to come back to the initial position, she is just taking 1 minute. And the length of this particular swimming pool is 90 meter. So she is taking 1 minute to cover 90 meter distance and to come back the same 90 meter distance. So in covering both the distances, she is taking 1 minute. So this is actually the data given in this particular problem. You should actually find out the average speed and average velocity. So what will be the average speed? So average speed always depend on the total distance traveled by a particular person or by a particular object divided by total time taken by that particular person or object to cover that particular total distance. So here total distance will be 90 plus 90. So that will be equal to 180 meter. So here total distance is 180 meter, and in 1 minute she is actually covering this particular 180 meter. So 1 minute will be there in denominator. So that is the total time which she is taking. So 180 meter divided by 1 minute. So what is 1 minute? 1 minute is actually 60 seconds, because in 1 minute you have 60 seconds. So if you are converting 1 minute into seconds, it will be 60 seconds. So 180 meter divided by 60 seconds will be there. So here 0 0 gets cancelled, 6 ones are 6 3s are 18. So that means 3 meter per second is the average speed of this particular girl. But now if you are considering the average velocity of this particular girl, whenever you are considering velocity, displacement comes into picture. When displacement comes into picture, direction will also come into the picture. So for initial 90 meter coverage, she is actually moving in forward direction. So it will be plus 90 meter. So that's why this plus indicates forward motion. Now she is actually traveling the same path in opposite direction to the initial direction. The initial path which she has covered, she is moving opposite to that. So the second time direction is actually the opposite to the initial direction. So that's why this particular displacement will be minus 90 meter. So if you consider total displacement by total time as your average velocity, then what is the total displacement? Total displacement is plus 90 minus 90 divided by total time is 1 minute. So what is plus 90 minus 90? Plus 90 minus 90 will be 0 divided by 1 minute. That means average velocity of this particular girl will be 0 meter per second. So that shows here displacement has not happened, because here displacement always depends on the initial and final position. So initially she was in the one end of a particular swimming pool. She has moved to the other end and came back to the same end. That means her final position is also on the same end, on the same initial position. So that's why here initial position and final position are same. Because initial position and final positions are same, displacement will be 0. So when displacement is 0, then average velocity will also be 0. But if you are considering speed, then you are not concerned about direction. So both 90 meter will be in positive. So it will be 90 plus 90, that is 180 meter divided by 1 minute or 60 seconds. So that will be 3 meter per second. That is the average speed. But when you take average velocity, it will be plus 90 meter minus 90 meter. So plus 90 minus 90 will be 0. So 0 displacement is there in 1 minute. So that's why the average velocity of that particular girl will be 0. So this is all there in this particular video. So the next concepts which are there in this particular chapter will be discussed in the subsequent videos. So like this, if you want to learn more physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.